Before cold storage, before chemical preservatives, before sealed containers and electricity, people still kept food stable across seasons, sieges, migrations, and long winters. This was not luck, and it was not constant drying or salting alone. Across multiple civilizations, a specific fungal method emerged that stopped spoilage by replacing chaos with order. The food did not rot because the right life forms took control first. This knowledge was once common, respected, and essential. Today, it survives mostly in fragments, hidden inside traditional foods and half-remembered practices. Why ancient societies realized that stopping spoilage meant managing life, not removing it. Early food keepers learned a hard truth quickly. Total sterility was impossible. Food exposed to air would always be colonized by something. The question was not whether life would grow, but which life would arrive first. Some organisms caused rapid decay and illness, while others, created stability, protection, and long-term preservation. The breakthrough came when people noticed that certain molds appeared early spread, evenly smelled clean, and, interestingly, halted further deterioration. Instead of rejecting all fungal growth, ancient cultures selected and encouraged specific ones. This decision turned mold from an enemy into a defensive system. The preservation power of this method came from dominance. When a beneficial fungus colonized a food's surface quickly, it consumed oxygen, altered surface chemistry, and released compounds that suppressed competing bacteria. Harmful organisms simply could not gain access. This is why cured meats covered in white mold or aged cheeses survived for months or even years. The fungus lived on the exterior, forming a stable boundary. Inside, the food remained protected, unchanged, and edible. The surface growth was not decay, it was defense. Ancient fungal preservation depended heavily on surroundings. Temperature, humidity, airflow salt content, and cleanliness all determined which organisms thrived. These conditions were refined over generations. Certain caves, cellars, smokehouses, and storage rooms gained reputations for reliability because they consistently produced the same safe results. These spaces were rarely scrubbed clean. Wood, stone, and clay surfaces carried beneficial spores. Tools and containers were reused deliberately. The preservation system extended beyond ingredients into architecture and routine. Fungal preservation rarely worked in isolation. It was almost always paired with fermentation. Before storage, foods were salted, cooked, soaked, or partially dried. Fermentation altered acidity and nutrient availability, making conditions hostile to spoilage bacteria. Once fermentation stabilized, the interior fungus claimed the exterior. This two-layer system explains the remarkable longevity of many traditional foods. The inside was biologically transformed. The outside was biologically guarded. Stable food meant mobility. Armies, relied on mold-protected cheeses, fermented grain pastes, and cured meats that could travel long distances without spoiling. These foods were dense, portable, and resilient. They survived heat, cold, and time. In many societies, fungal preserved foods were symbols of preparedness and skill. They were not emergency rations. They were strategic resources. Losing a fungal culture meant losing food security. There were no microscopes or chemical tests. Knowledge was sensory and inherited. Safe fungal growth had predictable color, texture, and smell. It spread evenly. It did not slime or liquefy food. Odors were sharp, nutty, or earthy rather than putrid. Dangerous growths were recognized quickly and discarded. This knowledge passed orally and visually from one generation to the next. Mistakes were remembered. Success became tradition. The value of this method today lies in understanding systems, not copying practices blindly. The lesson is not to let food mold casually. The lesson is that preservation works best when conditions are controlled so that only specific organisms can survive. Modern historians, food scientists, and traditional producers study these methods under controlled environments to understand resilience, not to gamble with safety. The principle applies far beyond food. Stability comes from directing processes, not trying to stop them entirely. Refrigeration, slows life. Fungal preservation, on the other hand, directs life. When refrigeration spread, biological preservation knowledge faded quickly. Food no longer needed active protection, just isolation and cold. But refrigeration depends on infrastructure, energy, and uninterrupted operation. The fungal method depended on understanding environment and biology. One system is fragile, the other endured for centuries. In a world facing supply instability, climate pressure, and technological dependence, the ability to preserve food without machines is not primitive knowledge. It is strategic intelligence. It shows how humans once achieved stability by cooperating with natural systems rather than overpowering them. If you value deep history, survival knowledge, and the overlooked technologies that sustained civilizations, subscribe to Echoes of Valor, share this with someone who studies the past seriously, and help keep alive the wisdom that once kept the world fed.